Okay, here's the actual process of how you go about completing the square to solve an equation. To actually do the completing the square format, you need your equation to be in x squared plus bx equals a number over here. Now, we don't care what number that is over there, but x squared or the value squared has to be by itself, and the bx has to be here, and nothing else. As you can see, the equation I need to work with, t squared plus 6t, is set up that way. Now, I'm going to pretend like I don't see this equals -5 because it doesn't help me complete the square. I'm going to try to figure out what I can add to t squared plus 6t to make it a perfect square trinomial. Now, perfect squared trinomials, something squared plus 2 times those original values plus something else. I figure out what that something else by doing that half of b squared. Well, b is 6, so half of 6 would be 3, and I'm writing and talking, don't do that. Half of 6 would be 3, and then 3 squared would give me 9. If I add 9 to this equation, now it's a perfect square trinomial. 6 or t squared plus 6t plus 9 is a perfect square trinomial. I can actually write that as a factor of a square of a binomial. T squared plus 6t plus 9 is the factored form t plus 3 squared. If you take t plus 3 times t plus 3, you will get t squared plus 6t plus 9. Now, let's go back and remember I had this equal to -5. Well, I changed this side of the equation by adding 9. Well, if you add 9 to this side of the equation, we've got to add 9 to this side of the equation. That gives us 4. Now, my factored form equals 4. The whole reason that we created the factored form is because I have something squared. I can undo something squared by square rooting. But if I square root on one side, you have to square root both sides. Take the square root of each side. Now that leaves me with t plus 3 equaling positive or -2. Now this is something I can solve. I have t plus 3 equaling these two different values. So if I subtract 3 from both sides, t could be, well, positive 2 minus 3, or, let me get this out of my way, move. Or if I'm thinking of the -2 square root, -2 minus 3 would give me -5. These are my two different answers. You can actually check, and they do work in the equation. So -1 squared would be 1 minus 6. That equals -5. And if I try to plug in -5, squared is 25 minus 30. That equals -5. These are the true values of the solution. So let's walk through that process again. Let's do that one again. Nope. Oh, I'm in the wrong spot. Sorry. Okay. Let's go to the checkpoint number 3. So let me walk you through this again. I have my x squared plus bx already by itself. I'm going to add something to this equation to make this a perfect square trinomial. And to decide what I'm going to add, I'm going to take half of b and then square it. Well, half of b is -4, and -4 squared would be 16. R squared minus 8r plus 16 is a perfect square trinomial. But that means I have to add 16 to this side too. So that gives me 25. The whole point of making it a perfect square trinomial is so that I can factor it to r minus 4 squared. Now look at the factored form I have. Do you remember when we took half of b and we got -4? And then we squared it to finish our perfect square trinomial, but that -4 ends up in our factored form. And that equals 25. If you actually multiply out r minus 4 squared, that's r squared minus 4r minus 4r. Hey, that's -8r plus 16. R squared minus 8r plus 16. What? This is our perfect square trinomial. We need to know that this perfect squared trinomial goes to this factored form. That's the whole deal here. To be able to complete the square, you need to know that perfect square trinomial turns into this factored form. Because now that it's in this factored form, I can get rid of that square by square rooting. And now r minus 4 equals positive or negative 5. I'm going to do plus 4 to positive 5 and plus 4 to negative 5. And I can even check my answers. 81 minus 72, yep, that equals 9. And 1 plus 8, and that equals 9 too. I know I have the right answers here. All right, let me walk you through the process of equations when they don't start off looking like x squared plus bx equaling a number. Well, first off, let's get rid of this plus 8. I'm going to have 4m squared minus 16m equals negative 8. And from here, I need x squared by itself, but right now there's a 4 in front of it. Let's divide all of these values by 4. That'd be m squared minus 4m equals negative 2. Now I'm ready to complete the square. What number do I need to add to make this a perfect square trinomial? Well, half of negative 4 is negative 2. Squared is 4. So m squared minus 4m plus 4. I've got to add 4 to this one as well. Now this is the perfect square trinomial of m minus 2, because that's going to give me negative 4m in the middle and positive 4 when I square it. And if that equals 2, I can undo that perfect square by square rooting it. And now m minus 2 equals positive or negative 1.4. Sometimes it might be helpful to, instead of write it like that, if you know you're going to have to take positive 1.4 and negative 1.4 plus 2, sometimes it might be easier to write that out. So that actually gives us 3.4, and negative 1.4 plus 2 is actually 0.6. If we plug in these values, they actually do work in this equation. So that's how you would go about doing that. Hopefully this helped clear up any questions you have on the process of completing the square. The key thing is to get it to be a perfect square trinomial. And the reason we get it to be a perfect square trinomial, x squared plus bx plus half of b squared, is so that we can factor it into x plus half of b. And then that binomial is then squared. So that is the whole key to completing the square. So good luck.